For this question, we have in the xy coordinate plane, is point R equidistant from points -3, -3, and 1, -3? So let's draw our coordinate plane really quick. So here we have a coordinate plane, and let's put on our coordinate plane these 2 points. So of course we have -3, -3, that's right here. And then we have +1, -3, which would fall right here. So what would be a center point? What could R be? Well, of course, they're both on the line -3, so that could be a valid y value. And then what would our valid x value be? Well, the middle of +1 and -3 is -1. All right, so a point like right here would be a valid solution. Let's look at statement 1. Statement 1 says the x-coordinate of point R is -1. So that's fantastic, but it just says the x-coordinate. So that tells me that it could fall anywhere on this line. Okay, let me redraw the line so that it matches a little bit better. There we go. So would any point on this line be equidistant? And while yes, it would be, because any point on this line, I mean, it would end up forming some sort of isosceles triangle. So any point on the line x equals -1 would be equidistant. So statement 1 is sufficient. What about statement 2? Statement 2 says point R lies on the line y equals -3. So the line y equals -3 is this line here. And we can already see that, well, if our point was right here in the middle, it would be equidistant, but our point could be here or it could be way over here. We don't know where the point falls on this line. Therefore, statement 2 is not sufficient information. So our answer here is going to be answer choice A. If 2x plus y equals 48, what is the value of y? Okay, statement 1 says x squared equals 81. So if x squared is equal to 81, then that means x is equal to plus or minus 9. Remember that when you take the square root, you have a plus and minus factor. So 2x plus y is equal to 48. So we can't determine what y is because we have 2 different values that we could plug in for x. So statement 1 is not sufficient. What about statement 2? Statement 2 says x minus y equals 2. All right. Well, if we have x minus y is equal to 2, now we have a system of equations, and we would be able to solve this system. And so statement 2 is sufficient. So our answer for this question is going to be answer choice B. Remember, for these problems, you just need to determine if you have sufficient information. You don't actually have to solve the problem. And so with statement 2, we're just able to determine that we do have enough information. And so that's how we can conclude that it is our answer. Each week, a certain salesman is paid a fixed amount equal to $300 plus a commission equal to 5% of the amount of his sales that week over $1,000. What is the total amount the salesman was paid last week? So we know that the salesman is paid $300 plus 5% of sales over $1,000. So this would be sales minus the first $1,000 he has in sales. Okay, statement 1 says the total amount the salesman was paid last week is equal to 10% of the amount of his sales last week. So if he was paid 10% of all of his sales, and this equals 300 plus 5% of sales minus $1,000, then we would be able to solve for S. Here we have one equation and one unknown. So statement 1 is sufficient in order for us to solve this problem. What about statement 2? Statement 2 says the salesman's sales last week totaled $5,000. Okay, well we know whatever our salesman is paid is equal to $300 plus 5% of his sales, which was $5,000, minus the initial $1,000. Okay, so here we just have straight up numbers, so we could figure out how much the salesman was paid. So our answer for this question is going to be choice D. Both statements 1 and 2 individually are sufficient to answer this question. At a bakery, all donuts are priced equally and all bagels are priced equally. What is the total price of 5 donuts and 3 bagels in the bakery? And statement 1 says, at the bakery, the total price of 10 donuts and 6 bagels is $12.90. So this tells us that 10 donuts plus 6 bagels is equal to $12.90. And what are we looking for? We're looking for the cost of 5 donuts and 3 bagels. Well, notice that this second equation, what we're looking for, is simply half of what we are given by statement 1. So we are able to determine this price. It would be $6.45. So statement 1 is sufficient. What about statement 2? Statement 2 says that at the bakery, the price of a donut is 15 cents less than the price of a bagel. So with this statement, we have the price of a donut is 15 cents less the price of a bagel. And that's all great, but without knowing the prices, we're not going to be able to determine the price of 5 donuts plus 3 bagels. So statement 2 is not sufficient. So our answer here is going to be choice A. Statement 1 alone is sufficient to answer this question. If r is greater than 0 and s is greater than 0, is r over s less than s over r? Well, let's look at statement 1. Statement 1 tells us that r over 3s is equal to 1/4. Okay, if we cross multiply, we can see that 3s is equal to 4r. And what does this imply? Well, this implies that s must be greater than r, as 3 s's would equal 4r, so s must be greater than r. Going back to the original question, is r over s less than s over r? Well, if s is greater than r, then we would have a smaller number over a bigger number, and a smaller number over a bigger number is going to be less than a bigger number over a smaller number. And so statement 1 is sufficient. What about statement 2? Statement 2 says s equals r plus 4. So let's clean this up just a tiny bit. We can get rid of this. If s is equal to r plus 4, then we can plug in r plus 4 for s, and we would be left with r over r plus 4 is less than r plus 4 over r. And again, we can see that we have a bigger value on top. Therefore, statement 2 is also sufficient. Therefore, our answer is going to be answer choice D. Both statements 1 and 2 independently give us sufficient information to answer this question. If a, b, c, and d are all positive numbers, is a over b less than c over d? Statement 1 tells us that 0 is less than c minus a over d minus b. If we multiply both sides by d minus b, we'd be left with 0 is less than c minus a. And so this tells me, this implies that c is greater than a. However, we don't know anything about our b and our d values. Therefore, statement 1 is not sufficient. If we look at statement 2, we are told that a times d over b times c squared is going to be less than just a times d over b times c. If what you have squared is smaller than what you start with, then that implies that what you start with, in this case AD over BC, is between 0 and 1. It must be a fraction between 0 and 1 in order for it being squared to be smaller than what you start with. So this also implies that BC, our denominator, must be greater than our numerator, AD. Going back to the original question, if we cross multiply, we would have AD is less than CB. And that's exactly what we have down here. So statement 2 is sufficient to answer this question. Therefore, our answer is going to be answer choice B. If x in these brackets denotes that the least integer greater than or equal to x, is x in brackets equal to 0? Okay, this is one of those problems that gives you a unique symbol. So what does statement 1 tell us? It says x is between -1 and 1. So some possibilities for x could include -1/2, or x could be +1/2. Again, x in brackets denotes the least integer greater than or equal to x. Well, the smallest integer greater than -1/2 is 0. And for x equals 1/2, the smallest integer greater than 1/2 is 1. So for statement 1, we have two different possibilities. Therefore, it alone is not sufficient. Statement 2 says x is less than 0. If x is less than 0, we could have something like x equal to -1, or we could have something like x is equal to -4.5. And again, if x in brackets is equal to the least integer greater than x, well, this would still be -1. And x in brackets here would be -4, as -4 is the least integer greater than -4.5. Okay, so again, statement 2 alone is not sufficient. Now let's put the two statements together. If we put the two statements together, then we have that x is greater than -1, but less than 0. Now with this, the only integer, like if we played with -1/2 again, -1/2 for x, as we already said, would mean that x in these brackets would be 0. And 0 is, no matter what, going to be the least integer greater than x if x is bound between -1 and 0. Therefore, both statements together are sufficient to answer the question, so our answer is choice C. If r and s are the roots of the equation x squared plus bx plus c equals 0, where b and c are constants, is r times s less than 0? So if r and s are roots, then that implies that I could write my equation as r, or x minus r, times x minus s, because r and s are roots. So we know, here let's FOIL this out. Well, firstly, we know that this equals x squared plus bx plus c. And if we FOIL out our left-hand side, we're left with x squared minus rx minus sx plus r times s. This implies that our c value is equal to r times s. So the only way r times s would be less than 0 is if our c value is less than 0. It has no bearing on our b value. So our answer for this question is going to be B. Statement 2 alone is sufficient to answer this question. if x is negative, is x less than negative 3? So statement 1 says that x squared is greater than 9. If I take the square root on both sides, then I'd be left with the absolute value of x is greater than 3. And the absolute value of x is greater than 3 implies two inequalities. It implies that x is either greater than 3, or it implies that x is less than negative 3. And as we're told in the question that x is negative, that means we're looking at this inequality here. Therefore, statement 1 alone is sufficient to answer the question. Statement 2 says x cubed is less than negative 9. We have x cubed is less than negative 9. Well, we're told in the question that x is negative, so if I just plug in negative 2 here, I have negative 2 cubed is negative 8, and negative 8 is not less than negative 9. Therefore, statement 2 is not sufficient, so my answer here is going to just be answer choice A. Statement 1 alone is sufficient. Material A costs $3 per kilo, and material B costs $5 per kilo. If 10 kilograms of material K consist of X kilograms of material A and Y kilograms of material B, is X greater than Y? So this question tells me that material K is equal to X kilos of material A, which cost $3, of course, plus Y kilos of B, which is $5. And of course, we also know that X plus Y is going to be equal to 10. And we want to know if X is greater than Y. Is there more portions of material A than material B? So statement 1 says Y is greater than 4. Well, if Y is greater than 4, then X could equal 5 and Y could equal 5. Or X could equal 4 and Y could equal 6. And we're asked if X is greater than Y. From statement 1, we're still not able to determine this because they could be equal or Y could be greater. So statement 1 is not sufficient. What about statement 2? Statement 2 says the cost of the 10 kilograms of material is less than $40. Okay. So let's clear this up just a tiny bit. Here, we're told that K is less than $40. So this cost of K is going to be less than $40. All right. So now we can kind of just plug in some numbers to see if it would work. So if X was 5 and Y was 5, then we would have 15 plus 25, and this equals 40. This is not less than, so we know that we won't be able to have the same amount of material in each. So this implies that we need to have fewer Y values and more X values. So statement 2 alone is sufficient to answer the question, so our answer is going to be answer choice B. What is the value of X if X cubed is less than X squared? Well, what does it imply if X cubed is less than X squared? This implies that X must be less than 1. And X must be less than 1 because if X is a fraction, then the cubed fraction will be less than the squared fraction. Or if X is negative, then a negative value cubed is still negative. However, a negative value squared would be positive. So X must be less than 1. And we also should note that we need to exclude 0 because if X is 0, of course, 0 cubed is equal to 0 squared. So let's look at statement 1. Statement 1 says negative 2 is less than X, which is less than 2. Well, we already know that X must be less than 1. but this first statement implies that x could be negative 1.9 or negative 1.8. We still don't know the value of x, so we don't have enough information here. Statement 1 is not sufficient. What about statement 2? Statement 2 says x is an integer greater than negative 2. Okay, so what are our options for x? X could be negative 1, 0, 1, 2, etc., etc. We also already know that x must be less than 1. And if x is less than 1, then it could be negative 1 or 0. However, we're told that x cubed is less than x squared, so 0 won't be possible. And so the only option left is that x is equal to negative 1. So statement 2 alone is sufficient. Our answer is going to be answer choice B. In the xy plane, the straight line graphs of the three equations above each contain the point PR. If a and b are constants, what is the value of b? All right, so let's draw our xy plane. And let's draw this second equation, x plus 6. Here we go. We have an x plus 6 line here. And in the question, we're asked to find the value of b such that a and b are constants. So statement 1 tells us that a is equal to 2. If a is equal to 2, then that implies that this equation is y equals 2x minus 5. And so if I graph this, of course this was an intercept of 6. Here we have negative 5 down here. So let's just draw another line. Here will be something like this, and let's extend this line out so we have some point of intersection. So here's our point of intersection. This would be our point PR. We would know this value PR because we could solve for the point of intersection with these two lines. We would just set 2x minus 5. We would set 2x minus 5 equal to x plus 6. And whenever we solved, we would have our point of intersection. At least we would have our x value, and then you would plug your x value in to find your y value. And then once we had our PR coordinate, we could use it and plug those values in for x and y here to solve for b. And so we would be able to solve for b just from knowing that the a value is 2, so statement 1 is sufficient. What about statement 2? Statement 2 tells us that our r value is equal to 17. Okay, our r is the y coordinate of our point. So we could use our middle function here, and we could say 17 equals x plus 6, and then we could solve for x and get that 11 equals x. So now we know that this full coordinate is 11, 17. Now we could take this coordinate and plug it into our third equation. And if we plugged it in to y equals 3x plus b, we would of course have 17 equals 3 times 11 plus b, and we would then be able to solve for b. So statement 2 is also sufficient. Just to clear things up a tiny bit, we're able to use this coordinate because we're told that it is shared in all three of our equations. Therefore, it must be the intersection point of all three of our lines. So, since both statements independently can answer our question, our answer choice is going to be choice D. If Q, S, and T are all different numbers, is Q less than S, which is less than T? So statement 1 looks a little complicated. Let's look at statement 2 first. Statement 2 just tells us that T is greater than Q. And that's fantastic. T needs to be greater than Q for our statement to be true. However, we don't know anything about S, so statement 2 is not going to be sufficient. So now let's look at statement 1. Statement 1 tells us that T minus Q is going to be equal to the absolute value of T minus S. plus the absolute value of s minus q. All right, here we can see on our right-hand side that we're going to be adding two absolute values together. So this implies that this sum will be positive. And since t minus q is equal to this sum, then it must also be positive. And if t minus q is positive, then this implies that t is greater than q. So that's fantastic, but we still don't know where s is. So does our right-hand side of our equation give us any insight to where s could be? So I think the best way to solve this problem would be to look at a bunch of different number lines and kind of determine which one fits. So here we have a few different options, right? We know that t is greater than q, so we could have t in the middle, q down here, and us up top. We could have s at the bottom, q in the middle, and t up top. Or we could have exactly what we're searching for, q at the bottom, then s, and then t. So the absolute value of a difference is just the distance between the two values on the number line. And in other words, this distance here from q to t is going to be our left-hand side of our equation, t minus q. Similarly, the distance from t to s is going to be the absolute value of t minus s, and the distance from q to s is going to be the absolute value of s minus q. All right, so we need to understand this a little bit in order to solve the problem. And looking at this, we can see that, hey, our t minus q is clearly not our s minus q plus our t minus s. If it would be way longer. It would be like way out here. And so this first number line is not going to be valid. Similarly, our second number line tells us that s minus q plus t minus s is equal to q minus t, or t minus q rather, and that's again not valid. Lastly, we have that t minus q, our big kahuna, is equal to t minus s plus s minus q. And this is valid. This is the only one that works with our statement. Therefore, our answer here is going to be statement A, answer choice A. Statement 1 alone is sufficient to answer this question. Last year, a certain company began manufacturing product X and sold every unit of product X that it produced. Last year, the company's total expenses for manufacturing product X was equal to $100,000 plus 5% of the company's total revenue from all the units of product X sold. If the company made a profit on product X last year, did the company sell more than 21,000 units of product X last year? Okay, so big question here. We're dealing with profit, revenue, and cost. So let's understand that profit is equal to your revenue minus our cost. And we're told in the question that our cost is equal to $100,000 plus 5% of our revenue. So if we plug this in for C, we would see that our profit is equal to our revenue minus 100,000 plus 5% of revenue. And if we simplify this, we'd be left with 95% of revenue minus 100,000 is going to be equal to our profit. Okay, so this is all just some notes to say about the problem before we look at our statements. So let's move this to the side. So what does statement 1 say? Statement 1 says the company's total revenue from the sale of product X last year was greater than $110,000. So that's fantastic that we know that the revenue was greater than $110,000. However, the question is asking us for the amount of units that were sold. And if we don't know a unit price, even with the revenue, we're not going to be able to determine how many units were sold. What if he was selling $50,000 cars? Then he only sold 2 or 3, right? But if he sold like 50-cent widgets, he sold a ton. So statement 1 is not going to be sufficient. What about statement 2? Statement 2 says for each unit of product X sold last year, the company's revenue was $5. This is something we can work with. Here we know that our revenue is going to equal 5 times X, where X is our number of units. So in the question, we're asked if we sold more than 21,000 units. Also in the question, we're told that we did make a profit. Okay? Since we did make a profit, then that implies that 95% of our revenue, and of course our revenue is 5x, minus 100,000 is going to be greater than 0. Now we can add 100,000 to both sides, and we have 100,000 is less than 95% of revenue, which is 5 times the number of units sold. Since all we want to know is if we sold more than 21,000 units, let's plug in 21,000 for X here. And if this value is less than 100,000, then we know that we must have sold more units than 21,000. However, if this value is more than 100,000, then it would be inconclusive. That would mean we either sold more or a little bit less. So we're hoping 95% of 5 times 21,000 is less than 100,000. So let's do that math now. So 5 times 21,000 is 105,000. And we want to know what 95% of this is. Well, I know 10% would be 10,500, which tells me 5% is 5,250. Therefore, 95% would be 5,250 subtracted from 105,000. And so this would be $99,750. So this is less than our $100,000 ask because we're told that we made a profit. And so this implies that we must have sold more than 21,000 widgets. So statement 2 is sufficient. Our answer is going to be choice B. If n and k are positive integers, is the square root of n plus k greater than 2 times the square root of n? So let's take this statement of the square root of n plus k being greater than 2 times the square root of n. And I'm going to change my right-hand side to be the square root of 4 times n. And I'm doing this just so I can place everything under a radical. And here now we can even square both sides and see that n plus k must be greater than 4n. This is just simpler to look at than what we were given in the original question. Now let's look at our statements. Statement 1 says k is greater than 3n. Well, if k is greater than 3n, then yes, n plus even just 3.1n would be 4.1n, which is clearly greater than 4n. So if k is greater than 3n, then yes, statement 1 is sufficient to answer this question. What about statement 2? Statement 2 says n plus k is greater than 3n. If n plus k is greater than 3n, then I could have something again like 3.1n, and this is not greater than 4n. I could also have something like 5n, and this would be greater than 4n. So statement 2 is inconclusive. Therefore, my answer is going to be A. Statement 1 alone is sufficient to answer this question. Machine X and Y work at their respective constant rates. How many more hours does it take machine Y working alone to fill a production order of a certain size than it takes machine X working alone? Okay, here we have a machine work problem. Sometimes these problems are complicated and confusing, so let me take a moment to explain how these problems work. So let's say up top we have machine X, and let's say it solves some problem in 5 hours. That means in 1 hour it will get 1/5 of the job done. Okay? And if we have machine Y and it's working on its own problem independently, and let's say it takes 10 hours to solve the problem, that means in 1 hour, 1/10 of the problem would be solved. However, let's say machine X and Y come together and start to be collaborative. Then we would add these works together in order to know that in 1 hour, 3/10 of the problem would be solved. If we wanted to know the total time spent, we simply reciprocate this fraction. It becomes 10/3, and we know that, hey, in 3 hours and 20 minutes, or in 3 1/3 hour, our whole problem would be solved if both machine X and Y work together. So there is a quick little refresher to how you can work with these problems. Let's look at statement 1. Statement 1 tells us that if machine X and Y work together to fill a production order of some size, then they take 2/3 the time that machine X would do when working alone. So that tells me that machine X does some portion and machine Y does some portion. And if we sum these, what would we get? Well, of course, we need to have a common denominator to sum these two fractions. So we can have Y over Y and X over X. And so this simplifies to X plus Y over X times Y. Again, recall that this equals 1 over the total time spent. Okay, so if we just want to know the total time, we're going to reciprocate this. So machine X and Y working together take X times Y over X plus Y hours, however much that may be. And in statement 1, we're told that this equals 2/3 the time it would take machine X to do the job alone. Now that we're here, we can simplify this down. So let's shrink this up and then continue solving the problem. Here I'll even change colors for us. So I can multiply both sides by 3/2, and I'll have 3 times xy over 2 times x plus y, and this equals x. Next, let me cross multiply. Of course, our right hand side is x over 1, so if I cross multiply, I'm going to have 3xy is equal to 2x squared plus 2xy. All right, now I can subtract 2xy from both sides and be left with xy is equal to 2x squared. And then I can divide by an x to have y equals 2x. So all this really tells me is that y works at half the speed as machine X. But so if machine X takes 1 hour, machine Y would take 2 hours. But this doesn't exactly tell me the difference. Machine X could take 4 and machine Y would then take 8. Okay, so I don't have a good grasp on the difference between the two. I just know it's half as long. So statement 1 is not sufficient. What about statement 2? Statement 2 says machine Y working alone fills a production order of this size in twice the time that machine X does when working alone. Okay, so machine 2 just tells me this right out the gate. Again, this is not enough information to solve the problem, and so our answer here is going to be choice E. Neither statement has sufficient information to solve the problem.